Hello. Today we are going to learn the Q learning of reinforcement learning. So as reinforcement learning, we know it is a repeated trial and error based learning where the motive is to earn the maximum reward of selecting the best action that will take to the better optimal state. So it is a trial and error based learning where Q learning is one of the most important uh, manifestation of reinforcement learning. There are some key ideas, there are some key concepts of reinforcement learning and Q learning in general. That is, firstly, the environment. The environment represents the external world, and the agent is the entity through which the reinforcement learning process is executed, through which it is supposed to be executed, all the process. It can be as simple as simulated game or as complex as a real world system, such as robotics, finance, or alike things. So the environment is the external world where the agent acts, where the agent have its activity. So the state, there is a concept of state. State means a particular arrangement in an environment, a particular organization, a particular combination of elements in an environment in a particular time step. The current situation or configuration of the environment at each time step, we can say also. So the arrangement of various elements, the arrangements of organization of various elements in a particular time step in an environment is called a state. The state is we can say it's equivalent to taking a snap of all the relative positions of all the elements. Suppose in a eight queens problem, the position of eight queens in a checkerboard. So likewise, all the relative position of all the elements in a particular environment is called a state. It provides the necessary information for the agent to make decisions. Agent is having some input. There's a platform of input where the agent can take a decision that where to go and which action to be taken to go to a better state so that we can arrive to a better state which is closer to the goal state. Now next, we have, after state, the concept of action that we have. Action is a step that is taken by the agent to change the state, to go to a change state. Why the action is chosen? Because of why this is because in order to proceed to a better state means in order to proceed towards goal, that is the objective of taking action. The action can lead you to a better state or the state closer to the goal, and the agent can earn a reward. This is a basic principle of reinforcement learning. And if the next state, by any misfortune, goes away from the goal state or is more distant from the goal state, the agent earns a penalty, which is called, often called regret, or which is often called a punishment, that is a negative reward. So actions basically are the choices that the agent can take in a given state to transit to a new state. Okay. And how the action is chosen? There are various ways the action can be chosen. The action can be chosen randomly, without any preconceived notion, without any predefined assumption, or the action can be chosen on the basis of some calculations, basis of some sort of predictions. That prediction is based on some so far yield outcomes. Analyzing the so far yield outcomes, the action can be predicted, action can be estimated. So these are the ways the action can be chosen. Policy. Policy is basically a state action pair. It is actually a state of rules that map between state and action. From a current state, which action will lead to which next state? Some current state is there. Which action can lead to which state? So it's a typical state action pair, the set of rules that has the parameters state and actions. Okay, the rules that tells from which state which action will be taken to transit to which destination state. So it is a strategy or decision making rule that the agent follows to select actions in different states. From n number of states to the n number of states is a from state 1 to state 5, state 2 to state 3, state 3 to state 7, like that, all state to all state, which actions to be taken, from which state to which state, transition is responsible, is actually crafted by which action. So these are set of rules that tells that. So it is a policy basically. It actually maps states to probability distribution over actions. If we want to change state 1 to state 5, the actions are given some probabilities. Action 1 is having some probability, say zero point 0.3. Action 2 is having some probability, say zero point 0.5. Action 3 is having some probability, say 0.01. Like that, all the actions are distributed by some probabilities, given some probabilities for transiting from the source state to the destination state or the starting state to the next state. Okay. So actions are actually given, assigned the probabilities, or the probability distributions are made over actions. Now the value function. The value function actually estimates, these are the key concepts before learning, going for the learning of the Q learning algorithm. The value function estimates the expected cumulative reward. It's a future expected cumulative reward that the agent can achieve from a specific state under its current policy. From state agent is standing on a particular state, the value function actually estimate the expected cumulative reward, expected total reward that the agent can achieve from by standing on a particular state by its current policy. Okay, that's the value function. That's the value of the state, we can say. It helps the agent to evaluate different states and make better decisions. So it is actually a quantitative score of a state, the value function. The Q function is actually it estimates the expected cumulative reward when an action is taken. Cumulative expected cumulative reward by taking an action A and transiting to a new state. Value function, while estimating a state only, it's evaluating a state's merit only, the merit of the state, how far it is from goal under its current policy. Q function actually evaluates an action from a given state. What is the merit of an action in order to transit to a new state or better state? The Q function estimates the expected cumulative reward. It actually estimates what is the cumulative reward. Reward means the capability of the action to take you to a better state. That is the reward. Cumulative reward means the total reward, whatever reward earned so far at the current state, plus the new reward, the fresh reward that is going to be earned when the agent wants to transit to a next state, the total cumulative reward, the expected total cumulative, because the future reward is expected, the expected cumulative reward that the agent can achieve by taking specific action, standing on a specific state. It helps the agent to evaluate the quality of actions in different states. Standing on a particular state, how the action is good to take you to a better state, that gives some reward. The, the quantification of the goodness of action is actually a reward point. And the cumulative reward evaluates an action, and the Q function is actually representing the cumulative reward by taking an action from a particular state. Initialization. Now, the reinforcement learning process actually starts with the initialization, interaction with the environment, learning, evaluation, optimization, and also definitely the updation of the parameters. So let's start the Q learning. Q learning is a model free. It is actually free of any preconceived model as a predefined model, predefined set model. It is actually a empirical way of going to the goal state, or empirical way of going to the reaching to the optimal state by selecting optimal actions. Actually, the algorithm learns an optimal policy. Policy means state action pair, what I told before, by estimating the value of state action pairs. Value of state action pairs, state action, from which state, which action will take to the better state and how much the state will be better. That is the evaluation of the action for a particular state. That is estimating the value of the state action pair, which is, other words, which is actually Q value. How the action is capable to earn a cumulative reward and what the cumulative reward is, that is the Q value due to an action taken. Updation is one of the thing, updating the Q value iteratively based on the observed reward and transitions. Based on the observed reward, if the reward is positive, means it is definitely is a positive reward, means it's beneficial for taking to a better state. And if the reward is negative, means it is taking to a worse state. So based on the reward, the Q values are updated. Now, before going starting the Q learning, we have to we have to analyze the method by which an action is taken. Standing on a state, first we have to take an action. The agent has to take an action. How the action is taken? Is it random or is it based on some pre-computed Q values, already computed Q values, and picking best Q values and choosing the action which is responsible for that best Q values or best cumulative reward? The action will be chosen in that case, which gives the best cumulative reward, the maximum cumulative reward, or the best Q value. Which one? The first one, choosing a random action, is an exploration, and choosing the maximum Q value on so far, the choosing that action that was responsible to earn a maximum expected Q value, that is the exploitation. Already, whatever we already have, we have to exploit the best of that. And exploration means we have to search for a new randomly. We have to test a new action randomly and test whether it's taking to a better state or not. Random. It is like a throwing stone in dark. The probability of success and failure are almost equal in choosing a random action. And for a exploitation, we have the exploitation tells that whatever the Q values we have already earned by taking various actions, we have to choose those actions, that action that was responsible to earn the maximum Q value or maximum cumulative reward. Which action can earn the maximum cumulative reward? So that is the exploitation. Now the algorithm starts is a concept. The epsilon greedy algorithm is a component, is a algorithm by which the action is chosen in Q learning. The Q learning choose an action according to the principle of epsilon greedy algorithm. Now, it can be either exploration or can be exploitation, and which, how much of exploration, how much of exploitation, and what is the trade-off between them determined by epsilon greedy algorithm. Algorithm starts with the Q value. Initial Q value is initialized at a certain stage of S. At certain state, we have to analyze the so far computed Q values. The Q table is an array of Q values. That is a Q table, we can say. That is a parameter Q representing that. The S represents the current state from where we have to take a decision of taking action. We have to choose action from current state. So current state is one of the parameter. Epsilon is a variable here that typically the starts with 1. Epsilon is a variable that typically starts with 1. Epsilon starts with 1. The parameter initialized by the 1 typically. So When the epsilon starts with 1, the third parameter epsilon, the loop starts, the iterative process starts. And the process goes till epsilon is 0. So epsilon starts from 1 at the beginning. The parameter epsilon is initialized by 1. And the loop, the iterative process or loop will go till the epsilon touches 0. So 1 to 0 it goes. And the step size, how it decreases. It can decrease by zero point 0.1. It can decrease by zero point 0.01. If it decreases by zero point 0.1, the zero point 0.1 is a step size or the learning rate or the amount of jump each step is having. There is the learning rate or the step size, the same concept. If the zero point 0.1 is the step size, then total iteration will have only 10 steps from 1 to 0. If the step size or the learning rate is 0.01, definitely the epsilon starts from 1, epsilon goes up to 0. So the total number of iterations needed will be 100. In this way, depending upon the step size, depending upon the amount of jump that we need, that we prefer, depending upon the learning rate that we prefer, the total number of iterations will be determined. So while epsilon greater than 0, the thing will be started. There is a random number generated between 0 and 1. The random number means the number which is absolutely without any priority between 0 and 1. So definitely zero point 0.1 is having the generation of zero point 0.1 between 0 and 1. There are 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0.5, 0.6, and so many numbers are there. And each number is having equal probability to be generated, equiprobable. All the values between 0 and 1 are equiprobable because it is randomly generated. That is n. N is a randomly generated number. So between 0 and 1 means between 0 and 1, whatever values we have, those are all equiprobable. All are equiprobable. So those are all having equal probability. And epsilon starts from 1 at the beginning parameter. Maybe it is not missed, not written here explicitly, but this is there. Now, if the randomly generated number, which can be 0.1, which can be 0.9, anything it can happen. If the random number less than epsilon, then the action will be chosen randomly. This means action will be chosen by exploration, full exploration. It will choose a new action. So at the initial stage, only exploration because we have not started at the starting stage. There is no Q value we have generated so far. There is no state transition has been taken place. No reward is earned. So naturally, there is no Q value is generated. So we can't go for exploitation. We don't have any Q values already generated. We don't have any rewards already earned. So we can't go for exploitation. We have to depend on the exploration. So when n less than epsilon, definitely A will be the random action. The A is assigned A. Capital A is the action taken, chosen action is a random action taken from the action space or the set of actions. Now, as the process goes on, the epsilon decreases by the step size. Baby step, for example, for simplicity, step size is 0.1. So next step, the second step, the epsilon becomes 0.9. So the second step, the number that can be from 0.1 to 0.9. Okay, from 0 to 1. Okay. The random number can be 0.1 to 0.9, anything, all are equiprobable. In that case, n less than epsilon, epsilon is 0.9, n less than epsilon will be the probability that the n less than epsilon will be 0.9. The probability that the n less than epsilon will be 0.9. So the action will be chosen. Action will be chosen. The zero point 0.9 cases, zero point 0.9 is a rate the action will be chosen in exploration. Why? Because n less than epsilon, the probability of n less than epsilon is 0.9. So 0.9 probability that the action will be chosen randomly. You see the line, if n less than epsilon, A will be assigned by the random action. So the probability of exploration is 0.9 if epsilon is 0.9. When epsilon was 1, n less than epsilon is a sure event because n can be zero point 0.1 to zero point 0.9. So definitely whatever values are there, it generated between zero point 0.1 to zero point 0.9, that is surely less than 1. So that is surely this if condition, first if condition is true, and surely the exploration would take place. Oh, or the action chosen will be a random. Now, as epsilon decreases, epsilon becomes zero point 0.8, zero point 0.7, zero point 0.6, zero point 0.5, like that. Slowly, slowly, the probability of exploration decreases and the probability of else part will increase. What is the else part? The action will be chosen. The action. The action will be chosen. Action, the new action that is going to be chosen from the old actions. That action, that old action that was responsible to earn the maximum Q value, which was responsible to earn the maximum Q value. So it was responsible to earn the maximum Q value that we have. That is the action, new action will be chosen from the set of actions in the action space, which was responsible to earn the maximum Q value so far. That action will be taken from the current state. Now, from the current state, we'll estimate that which action will maximize the cumulative reward. Whatever reward earned so far that we have, whatever Q values are there, whatever the last updated Q values we have in the current state that we have to estimate an action. We have to take an action by estimating an action that would earn the maximum cumulative reward for the next step, up to the next state, or the maximum is Q value up to the next state. Which new action will be taken that will maximize the reward till the next state or maximize the Q value till the next state, we'll take that action only. So it is an exploitation. The probability of this else will increase as epsilon decreases. As epsilon becomes zero point 0.5, probability of exploration is zero point 0.5, probability of exploitation is also zero point 0.5, because the random number less than epsilon, the probability that the random number less than epsilon is zero point 0.5, and the probability, the else part, probability of the random number greater than equal to epsilon is also zero point 0.5. So we have the 50% chance probability or 50% rate of exploration, 50% probability of 50% rate of exploitation as well. Now, if epsilon decreases further, the rate of exploration or the probability of exploration will decrease. The rate of exploitation or probability of exploitation will increase. In this way, at the last stage, there is no exploration or exploration is about to be uh, obsolete and the exploitation takes over. It is all exploitation through which the action is chosen. When there is an adequate number of Q values are generated, adequate cumulative reward is generated, adequate states are visited. So now the agent will go for the exploitation, whatever is done so far. We have to take best of from the pool, whatever is done so far. Okay. Now, this is the epsilon greedy for choosing the optimal action. Now the Q learning starts from the initializing the Q value arbitrarily for all state action pairs. Now we have to set the learning rule alpha and the discount factor gamma. What is the learning rate? Learning rate means the step size, the amount of jump from one state to the another state, one step to the another step in an iterative process. Q learning is also an iterative process. Discount factor gamma, we will learn later as we proceed with the algorithm. It is a discounted value of the future return in terms of the current period. Now we have to repeat for these steps. Initialize state S. Repeat for each time step in episode. Episode means from a particular state, whatsoever states we can visit. That state is the state of one particular state, given a source state, whatever number of actions we can take in and whatever number of states we can visit, that thing is called an episode from a given state. From state 1 to all n number of states, mapping from state 1 to all n number of states by taking n number of actions is called an episode. So one episode determines from one state how can the what is the best action to be chosen that will lead you to the best possible state from state 1. Similarly, the second episode, another episode we can tell from state 5, what is the best action to be chosen that will take the agent to a best state. So now these are repeat for each time step in the episode. Episode means the source state is given and it is analyzed for all actions what the destination states will be. Now choose an action using an exploration exploitation policy. According to the epsilon greedy, the action is chosen according to the epsilon greedy. What I told, the proper balance of exploration exploitation. At the initial stage, there will be exploration. As the process goes forward, the exploration decreases, exploitation increases. And at the last stage, there is no exploration, there is only exploitation. So in this exploitation trade-off, the action is chosen. Take an action A according to the epsilon greedy and observe the next state S and the immediate reward that is earned R. By taking an action A according to the epsilon greedy, we are going to the next state and analyzing the next state, how good better the next state is in terms of the distance from the goal state, the agent earns a reward that is R. After earning the reward, the R can be positive or can be negative. If it is going to a worse state, R can be negative. If it is better than the current state, in terms of the distance from the goal state, it is positive. Now the Q value is updated. Q value is nothing but it is actually storing the cumulative reward inside. It is actually representing the cumulative reward, taking the new reward in consideration and having the old Q value that is also embedding the cumulative reward up to the previous period. Okay. Actually, by this way, the Q value represents the cumulative reward, the total cumulative reward. Now, QSA, the left side QSA, as we can see, the left side QSA, Q as a function of state and action, is a updated QSA. The right side QSA is a unupdated QSA. Alpha is the learning rate or the step size multiplied by R, the current reward. Gamma means it's a discount factor of the maximum estimated Q value for the next period, the maximum estimated Q value for the next period, minus the current Q value, whatever Q value earned so far. Maximum estimated Q value up to next period by taking an action A prime in the current state. We are staying in the current state S. We are taking an action A prime that will lead to a new state S prime. And we are estimating the Q values for all the possible actions that will take you to the possible S prime states. And we pick up the maximum of that, the maximum action, the action that will pick up that action that will maximize these Q values that is earned by going to all the possible next states. So actually the maximum expectation we can say. This part, maximum Q S prime A prime is a maximized expectation or expected maximum Q value. And why it is discounted? Because it is a future expectation. When we transit to the next state S prime, then what the Q value we will be earning, we are estimating that and the maximum value of particular Q value that is going to be earned in the next state. So it's a future return, expected future return multiplied by the discount factor to scale it according to the current state. To scale it according to the current state, we have to multiply it with gamma, the discount factor, minus the current Q value, currently updated Q value. What is the present Q value? Present updated Q value that we have. This total component, first of all, the gamma into max Q S prime A prime minus QSA, that is actually the additional Q value that is expected to be earned for the next period. The additional Q value. Exactly the additional minus QSA, whatever Q value we have already earned, that is subtracted from the expected maximum Q value, definitely multiplied by the discount factor for the current period to frame it in from the to present it in the current period, plus the current reward, immediate reward. So this total term inside this bracket is total term represents the outcome. First, the gamma into max q s prime minus QSA is a additional outcome or the additional benefit we are going to earn by taking action A prime. The additional, the how much Q value is going to be added, how much Q value is going to be earned additionally from current state to next state, plus the current reward that we have earned. So this is actually the total expected return. This is actually the total expected return, taking consideration the current reward and the next expected Q value, minus the whatever Q value we have earned. So that is actually the expected benefit. This is actually expected benefit uh, by taking an action A prime. Whatever expected benefit we have, that is all inside the bracket. R plus gamma into max QS prime A prime minus QSA is the expected benefit up to the next state. Definitely multiplied by the learning rate. Learning rate means the step size, the cost we have to bear to achieve that particular benefit. The cost agent has to bear. The alpha means the learning rate, the rate of learning, or the step size, or the amount of step, it has, amount of space, yes, it has to cover to transit from one state to another. So definitely the cost. It is a cost bear to achieve the particular benefit. So that's why it is multiplied with alpha to actually represent that how much actual benefit that you are going to earn for up to the next period, plus the current already earned Q value, plus already earned Q value. So that will definitely estimate the total cumulative Q value, total cumulative reward, and current Q value QSA in the right side, what we can say that embeds the cumulative reward till today, till now, till current state, whatever cumulative reward is earned, plus the total expected cumulative reward, plus total expected um, additional reward that up to the next state. So this is a cumulative, definitely cumulative reward, or the total Q value, or the aggregate Q value till the next state from the beginning. So this is actually from starting to the current state, and the second part is current state to the next state. So starting to the current state, this Q value is earned. From current state to the next state, expected Q value is this one, the second part. Alpha into R plus gamma into max QS prime A prime minus QSA. That whole part is the expected additional Q value that we are going to earn up to the next, from current state to the next state. So adding these two, definitely it's a cumulative reward or the total Q value that is going to be expected to be earned up to the next state. So that is updated. The Q value is updated by that rule. So this is a new Q value. When we arrive at the state S prime, this left side QSA will be the new Q value. Move to the next state S prime. End of training. Now what happened? This is a Q learning, and there are other things are there as we have. That is after that moving to the next state. Then we have to terminate the episode. This is for one episode. This is for one episode. And for one state, we are going to the optimal next state. From other states also, taking the other states at the third starting state, from the other states as the starting state, we have to also find out the best state from those states. So for all episodes, the process from the 2 to 5 will be repeated. The steps from 2 to 5 will be repeated for all episodes, means all starting states. All starting states. So that is repeated for multiple episodes. Episode will be terminated for one state, one source state. The process is terminated, then it will repeat for all the starting states. So finally, it will converge to the Q value is converging to the optimal values, okay, which represents the maximum expected cumulative reward for each state action pair, not one state to the other state or all state action pairs, okay, which is the best one, best Q value for all state action pair from each source for all source states from all source states to all destination states by taking any action, okay, for all state action pairs, starting state, action, next state, for all combinations, all possible combinations, the best optimal Q value that is generated. And after that, the policy is updated, policy extraction. So policy will be assigned by the policy is having state and action as the two major components. The action of a policy is updated by taking the action, by taking action that will give you the optimal Q value. That will give you the optimal Q value, give the agent the optimal Q value. The action which is responsible to give the agent the maximum Q value, that action will be chosen to be assigned to the policy. Policy will be updated by that action for all state action pairs. For all state, this is not for one state, one action. For all actions, this rule is applicable. The policy is assigned by the argmax QSA means policy is assigned by that action, state action pair. Policy is assigned by that state action pair for which the Q value is maximized. The policy is assigned by those state action pairs. Policy is a state action pair. The policy itself is a state action pair that will be updated by those state action pairs for which the Q value goes its maximum or optimal. After that, the process is terminated. So we have, this is all for Q learning. First of all, we have to judge each episode, means considering each starting state. Taking one state as given, one starting state as given, one state as given to be starting state, we have one episode. Means from one starting state, we are having n number of destination states. We are having n number of possible actions to be taken. We have to choose the best action that will take you to the best state from the current given current state. Similarly, we are having n number of current states. We can choose n number of current state and we can choose the best action subsequently that will take you to the best state from that particular state. After completing all the episodes, we are comparing all the best actions. Which is the best actions? That means which is the best Q value. We will take that best Q value and we will take the action responsible to make that best Q value. And that action will be that state action pair. That will be the policy. The policy will be assigned by that state action pair. Thank you so much. Now, next lecture videos, we will be learning the Markov decision process, MDP, and the connection of Q learning with MDP and other advanced topics, advanced issues. Thank you.